Assalamualaikum warahmatullahi wabarakatuh, and I hope everyone have a great day. So today I am going to present my mini project, which is an ECG263 individual assignment. So my name is Arisha Binti Anuar, and my matrix card number is 2020613392, and I am from class EC 11046. So we are going to start our presentation today by the first lab, which is particle density. The objective of this lab is to determine the specific gravity of soil using density bottle. The apparatus used in the lab is a density bottle with stopper, having a capillary hole at its center, wash bottle, the air distilled water, vacuum set. However, since the lab is not available to use at the moment, we decide to use uh, our own our own equipment, which is as shown in.
For M2, put the soil sample into the jar and record the mass. Fill the jar with distilled water after adding a few of distilled water and record the weight for M3. Lastly, clean the jar and fill it up with distilled water only for M4.
Next, the result. To determine specific gravity of the soil is used a formula is used as shown in the picture, and this is the data that we have recorded. The temperature is 31 Celsius, and the weight of bottle is different, but they are slightly the same. And then we get the specific gravity after we are done with our calculation. For the first one, 2.66, second one, 2.65, third one, 2.65. And then we need to get the value, the average value, which is 2.65.
Moving on to the discussion. The experiment has been conducted for 3 times in order to obtain the average specific gravity. The weight of the bottle or M1 for each observation has been recorded respectively. When the dry soil sample is poured into the bottle, the mass increases for all 3 samples. By using the data obtained, specific gravity for each observation can be calculated by using the formula. Specific gravity GS equals to M3 minus M1 divided by M3 minus M4 minus M1 minus M2 minus M1. The average specific is calculated by adding the 3 results and divide them by 3. The desired result obtained is 2.65. In conclusion, the objective of this experiment, which is to determine the specific gravity of soil, has been fulfilled by using density bottle. The recorded specific gravity is by conducting this laboratory session is 2.65 averaging. Thank you.
Moving on to the next experiment, which is moisture content. The objective of this experiment is to determine the moisture water content of soil samples. The apparatus used is as below: container, pan, electronic weighing scale, wet soil, dry oven, and spatula.
The empty container is weighed and the mass obtained is recorded as M1. The wet soil is poured into the empty container. The mass of the container plus wet soil is weighed and recorded as M2. The procedures are repeated for another 2 samples. The samples are put into the dry oven for a day. After 1 day, the samples are taken out . The mass of the container plus dry soil M3 is recorded.
Moving on, this is the result. So as we can see, we have prepared 3 container, 1, 2, 3, and then we have recorded the mass of container for M1, mass of container plus wet soil for M2, and then mass of container plus dry soil M3 after 1 day of drying. And then we calculate the mass of moisture soil M2 minus M3. And moving on, we get the moisture content of water, which is for the first one, 15.15, 23.33, 14.29. The calculation is as shown below.
So discussion. Moisture exists within the pore spaces in between soil aggregates, inter-aggregate pore space, and within the soil aggregate, intra-aggregate pore space. Usually, air, and or water are the ones occupying this pore space. This experiment begins with the preparing three different containers with the same soil sample in order to get an average result by the end of the experiment. Each of the containers are labeled as 1, 2, and 3. In order to obtain moisture content W, a calculation is done by using this formula, which is moisture content W equals to M3 minus M2 divided by M3 minus M1, and then we multiply it by 100. Each moisture content values are added and divided by 3 to get the average moisture content value. W average is recorded as 17.59%. In conclusion, the experiment has successfully achieved the objective to determine moisture content of the soil sample, which is 17.59%. Most natural soils, which have gravel and sandy in nature, may have water content up to 50 to 20%. Thank you.
The next one would be particle size grading and texture. The objective is to determine the percentage of different grain sizes contained within a soil. The apparatus used are as below: a balance that readable and accurate to 0.5 gram, set of sieve, cleaning brush, mechanical sieve shaker, lid and receiver.
Clean each of the sieving pans by brushing the dust off and measure each of the mass separately and put a 200 gram soil into it from the top to the bottom and then put it on the machine to shake for 15 minutes. After that, take it out and then record the mass of retained soil.
Pan. The result is as shown here. Firstly, the mass of sieve pan and soil is as recorded in the third table for stage 1 and stage 2. And then moving on, we have cumulative percentage. Okay. And then I have included a graph for the experiment.
Okay, discussion. The data is obtained by weighing the remaining soil on the sieve pan and recorded in the table. From the data, percentage retained can be calculated by using this formula. Mass of soil retained in a sieve divided by initial mass of dry soil and then multiplied by 100. After that, cumulative percentage is calculated with this equation. Cumulative passing equals to 100 minus percentage retained. To the result, the soil sample has shown that it has the biggest percentage, which is 50% around the sand area. Conclusion: to conclude, the soil sample mainly consists of sand-sized particles since it has the highest percentage of soil remain after passing through 4.05 mm until 0.075 mm sieve pan.
The fourth one will be field density test. The objective is to determine dry density of in situ soils. Apparatus: set of pouring cylinder, Ottawa sand, passing 1 mm and retaining 0.6 mm.
By using calibration cylinder, the weight of corn that is produced under the pouring cylinder is determined by weighing the weight of that corn produced. Expose an area about 550 mm square on the surface of soil mass. Place the metal tray on the level surface. Excavate the soil through the central hole.
The result is as shown in this table. The volume of calibration cylinder 0.1178 meter cubic, and then the mass of sand inside cylinder plus corn sand in kg is also calculated, which is 2.075. This is obtained from the experiment. And then mass of corn sand, mass of sand inside cylinder, and lastly density of pouring sand kg over meter cubic. Okay, the calculation below is how we got density by dividing 1.581 to 0.1178, and then we got 13.42. The second one is the field result. This is shown in the table, and this is a field sample calculation from how we get the result.
Discussion. By using the data obtained, a calculation to get the value for moisture content of removed soil has been done, which is 3.71%. The volume of calibration cylinder is 0.1178 meter cubic. This value will be used to calculate density of pouring sand, and the calculated value is 13.42 kg over meter cubic. This value later will be used to obtain bulk density and dry density by using these two formulas. Bulk density of in situ soil equal to total mass over total volume, and dry density of in situ soil equals to bulk density over W1 plus W. In conclusion, the sand replacement test method is used to determine the in-place density of compacted soil in order to compare it with the designated compaction degree. Hence, it specifies how much the compaction of the soil is close to designated compaction degree. The bulk density is recorded is 39.93, while the dry density value is 38.50.
The last one is permeability, constant head test, to determine the coefficient of permeability of coarse-grained soil. Apparatus: permeameter, complete with accessory, DA water, balance, mixing pan, graduated measuring cylinder, meter scale, stopwatch.
Open the valve to fill the water from the reservoir to the tank. The water will flow into standpipe. Wait for the water inside the standpipe to be constant at a steady state. The water will flow out from the outlet and into the cylinder measurement. In every increment of 5 seconds, record the quantity of water collected. The time will be up to 30 seconds.
And beaker. So the result is as tabulated here. The most important data is overall average coefficient of permeability of soil sample km over second, which is 0.2462. But note that the data is obtained by constantly by making the time taken constant from for 5-second interval, so the quantity of water can be different.
Discussion. The soil sample has a cylindrical form, with its diameter being large enough in order to be representative of the tested soil. Rounded particle will have more permeability than angular shape. It is due to specific surface area of angular particle is more compared to rounded particles. The coefficient of permeability K is calculated by using this formula. K equals to QL over AHT, and the unit is cm over second. The soil type. The overall average coefficient of permeability of soil sample K is 0.2462 m over second. For this table, K is around coarse grade sand, since the average K calculated is estimated. In conclusion, the objectives of this experiment to determine the coefficient of permeability of coarse-grained soils is achieved since K equals to 0.2462 m over second.
Lastly, my personal point of view of this project. I think it's good because I can revise the laboratory experiment again while completing it. It is graded individually, which motivates me to do better since it will be 100% of my effort. It helps me to understand the laboratory even better since it requires a lot of reading to complete this report. Thank you.